Alan Brown is with Nagase ChemteX, and he'll be telling us about advances in wash testing of conductive inks for wearable electronics. And actually, I have to say thank you very much, Alan, because Alan and Nagase are now our gold sponsors. So we really appreciate it. Thank you very much for that. So yeah, Alan, when you're ready, do share your slides and we can jump right into it.
Thanks, Kasha. Thanks for giving us the opportunity to present here today as well. So today I'm going to talk a bit about some progress that NCU or Nagase ChemteX has made with conductive ink wash testing, which has been a critical component as more products go into the wearable electronics applications. So, I will talk about test objectives and test processes, the results, and then, what we've concluded today and the future work that we are going to do. So the process and objectives, our testing was done off-site at AETCC. We followed test method 61 while also referencing IEC 63203. Wash testing was done at 30 degree water temperature. They were put in canisters, and a 45-minute wash cycle is the equivalent of 5 standard wash cycles at home. Our initial goal in the testing we've been doing, based on some requirements that we've talked with folks in the industry, is we are looking at a 2.5 time increase in resistance to use as a failure point. And this could obviously vary based on user requirements. The goal being to provide users with a robust print stack up. And, we've looked at silver and carbon stack ups, a carbon, silver, carbon stack up, looking at the impact of which TPU substrate is used and transferred to a textile. And then we're also looking at the impact of the conductive ink chemistry and how that impacts the washability. So this gives you a look at how our test specimens were stacked up. We did testing with carbon printed on TPU, silver printed followed by carbon, and then carbon, silver, carbon to see how all of these compared when doing wash testing. Of those stack ups, resistance was measured in the following locations. And this is the test pattern here. And this one here is just a carbon pattern that we had the TPU transferred to the textile. And to be consistent with the resistance measurements, the probes were placed on the 2 pads at the end of the test specimen. The results on what I will describe as substrate A, where we had several different samples that went into this testing. With again, the goal here to be which stack up gave us the most robust performance, will show that, the only carbon, silver, carbon will survive 20 wash cycles with a target resistance increase of 2.5x or less than 150%. While also looking at alternative commercially available NCU conductive inks, we did not get good results, and that can be seen. So based on some of the initial results that we had done, we also wanted to take a look and see how the TPU substrate may impact the washability of these circuits. And we found some interesting results. Here, and again, the initial testing here is just the silver and carbon stack up. And if I go back a slide, when we look at a carbon silver stack up, we were getting about 10 wash cycles. So to throw another substrate into the equation, we found that